In this section of Chapter 10, we're going to be talking about the Hofmann elimination. For the Hofmann elimination, we're going to take amines and we are going to convert them into alkenes through the elimination of an NCH3 unit. So with this process, we're going to take an amine and we're going to walk it through a series of steps to get to an alkene. The first step is we're going to use CH3I, so methyl iodide, and we're going to make sure that we have a lot of excess of this methyl iodide. From here, we're then going to react with Ag2O. This Ag2O is really just going to react as a base for us in solution and allow us to do some acid-base chemistry. From there, we're going to use heat to drive us to our final alkene product. Our alkene product is going to be the anti-Zaitsev product because we're going to be removing this very large, bulky base, and that large, bulky base is going to help us remove protons from the less substituted site. So we're going to get that anti-Zaitsev product, which is the less substituted alkene or the less stable alkene that we will be looking at. The large bulky base that we're going to be driving off is going to be that NCH3 unit is going to be what we're driving off or eliminating from our compound. So let's look at the mechanism associated with our Hofmann elimination. So we have our amine and then we have our alkyl halide. That nitrogen on the amine is going to behave as our nucleophile with our alkyl halide. So basically we're going to be putting a methyl group on that nitrogen. That gives then the nitrogen a positive formal 1 charge. We will go then through a deprotonation process. Since we are under basic conditions with all of our amines, we will see a deprotonation of that nitrogen. So now it has 1 CH3 unit and it has 1 hydrogen on it. And we have also then generated a protonated amine, which would be neutralized by the I-. We're then going to continue to repeat this process in this scenario 2 more times until there are no more hydrogens on the nitrogen to remove. So we have generated now that nitrogen with 3 CH3 units and the formal positive charge. So there are no hydrogens that we can deprotonate to make that nitrogen neutral. We've reached that ammonium salt level. So now what we're going to do is we are going to put then our Ag2O in solution. Basically, the silver oxide will react with the iodine in solution to produce hydroxide ions. So it's kind of another way that we can put it under basic conditions without actually having to put in a strong metal hydroxide base. So then what this base is going to do is it is going to react with the less substituted side and see a deprotonation there. That is then going to drive off through that elimination process, that E2 type mechanism. It's going to then drive off that protonated amine leaving group, which will leave as a neutral compound for us. So this then leaves us with our alkene. But again, it's the less stable alkene. We're looking at deprotonating the less substituted side. Since that nitrogen is so big and bulky, we're driving off on the less substituted side. And then we would also have our NCH3 unit or trimethylamine that we would have driven off of our alkene. So this is our Hofmann elimination. It's a very specific elimination that allows us to produce the anti-Zaitsev product or the less substituted or less stable alkene through the elimination of the trimethylamine.